about the preparation of haloalkanes from alcohols. The reaction number 3. It is the action of PCl5 on the alcohol. The general formula of alcohol is ROH. PCl5 is phosphorus pentachloride. That gives a reaction, it is called as RCl, chloro derivative of alkane, haloalkane, and that is Cl replaces OH. It is removed as along with this POCl3 and Cl, that is byproducts, RCl. This chemical activity, either PCl5, you see that PCl5 can exist in either in the gaseous state or in the solid state. If we use PCl5 as a gas in the reaction or PCl5 as a solid in the reaction mechanisms are different, but the product remains same. Reaction mechanisms are different, but the products are same. What is reaction mechanism? Between the molecules, what chemical bonds break, what new chemical bonds form, how those chemical bonds break, how those new chemical bond forms. That is the details about this is called reaction mechanism. This is finds applications, and because these organic reactions involving multi steps, you need to understand in what steps what chemical bonds broken and what chemical bonds are forming. That is called as reaction mechanism. Let us understand the reaction mechanism in this PCl5 as a gas. If I write simply PCl5, it is understood as a gas only. That is why PCl5 is a gas. Look at that, the structure of the alcohol in this oxygen of the hydroxyl group contains 2 lone pair of electrons. This phosphorus is reactive towards oxygen. So this lone pair of electron tends to form a chemical bond, sharing both the electrons for bond formation. This tendency, what is that, leaves a positive because electron deficient, both electrons are shared, becomes positive with chemical bond formation. This with new chemical bond formation, there must be one chemical bond break on at least to satisfy the valency. This chemical bond breaks away Cl minus during this formation. So Cl minus plus, that is neutral together, these two are Cl minus plus. Next is the intermediate formation. This is again reactive. So this undergo what kind of reaction? This chemical bond breaks and breaks away as H plus hydrogen ion, giving 2 electrons to this, forming this neutral. Okay, lone pair of electrons. That H plus is removed from this step. This H plus and Cl minus combine to give HCl. That is why one HCl molecule is released. Now with this, another intermediate formation is formed. There is one intermediate changing from another intermediate. This intermediate, there is only one molecule, undergo what is that? Some chemical bond rearrangement. What is the rearrangement? That is chemical bond. This chemical bond now unstable. This new chemical bond is beginning to form. So new chemical bond begins to form. This chemical bond begins to break away as Cl minus. As this chemical bond begins to break, as a result of this breaks away, giving 2 electrons, both electrons to this, and rest become a positive charge of the carbon. This Cl minus breaking away as try to attack the same carbon plus. This all simultaneous. No separation, right? So that is why you can know this chemical bond, new chemical bond, this chemical bond breaking, new chemical bond begins to break, new chemical, this chemical bond break, all is dotted line, new chemical bond. So this will form, this will break, this will break, this will form, all simultaneous attack. So forming what is that finally? What is that? This is broken away as this, and this forming chemical bond with this. So this double bond becomes solid line, and this is broken, that is broken. So the product is this. So finally, product formation, it is a rearrangement within the molecule, internal rearrangement, not between the molecules. This is one molecule rearrangement like this, isn't it? One molecule. Within that molecule rearrangement, the nucleophile will attack this. Nucleophile will attack the carbocation like this. Simultaneous breaking and forming. So this rearrangement is called as internal, intramolecular rearrangement within the molecule, not between the molecule. So it is called as, the mechanism is called as intramolecular nucleophile substitution. This kind of rearrangement, the nucleophile attack within that molecule is called intramolecular nucleophilic substitution. Because it is not breaking away, attacking from this side, breaking this. It is same side. Because it is not away from here, not broken away. It is attacking from here. That is why it is attacking the same side. So this Cl is bonded to the same side of that of hydroxyl group of the R group. That is, geometry is retained. Right side, right side. It is called SNI mechanism. What is SNI mechanism? Intramolecular. I stands for intramolecular nucleophilic substitution. This geometry we will talk about. If the carbon, that is carbocation of this carbon is chiral, what is meant by chiral? Every carbon in the hydrocarbon molecule is bonded by, what is connected by 4 chemical bonds. These 4 chemical bonds are arranged in tetrahedral fashion. What is tetrahedral fashion? The molecule, a carbon of the molecule is neither linear nor planar. It is a 3-dimensional geometry. That is, 4 chemical bonds are arranged in 4 different directions in space. 4 equal directions in space, spatial arrangement. So, spatial orientation. The bonds are spatially oriented. The angle between any 2 bonds is around about 109 degrees. That is a spatial arrangement. Tetrahedral, that is called tetrahedral fashion, tetrahedral geometry. If bonding connected, no, it is 4 different groups. If all the bonds, what is that? Connected with 4 different groups, that is OH, here H, that is benzene and CH3. That carbon is called as chiral carbon or asymmetric carbon. Asymmetric carbon. So that is called as chiral carbon because this is geometry is called as stereogeometrical configuration. Look at this. That is alcohol. This alcohol gives this halide. That means this alcohol, because if this is the reactant, this is the product. OH is on the same side, Cl is on the same side. That is called retention. Geometry is retention, retained. The stereogeometrical configuration is retained even after the reaction. It is called retention. In some reactions, it is because what is that? Reaction remains same. It is stereo configuration is reversed. Okay, no? That is on the left hand side, Cl side, not on the right hand side. This will go to other side. Interchange. It is called inverted. The geometrical stereoisometric geometry is inverted. It is called inversion. In some reaction, it gives both. This and this mixture is called as racemic mixture. Both these 2 configurations. And these 2 configurations, what is that? Are stereoisomers. And look at this geometry of these 2 molecules. If you look at carefully about the geometry of this molecule, this is exactly the mirror image of this. This is exactly the mirror image of this, either way. What is mirror image? The image of the object in the mirror is always inverted. What is meant by inverted? Right becomes left, left becomes right. But that is the top and bottom, up and down, remain same. Only left and right sides are inverted. It is called inversion, mirror image. That is the mirror property of the image. So, if this is the configuration, these 2 are called as stereoisomers. These two stereo isomers are designated as, designation is there. So accordingly, what is that? The priorities of the groups. So it is depends on the higher to lower priority. Higher priority is on the basis of the atomic number. So it is the highest atomic number here, carbon double bond, carbon single bond. So carbon has lower atomic number. The priority with respect to this bond, it is the lowest priority, least atomic number. About this chemical bond, the priority, that is what is that? Next, first this, next this. That is anti-clockwise direction, is called S configuration. This stereo isomer is called as S configuration. But look at this configuration. Here first Cl, then this carbon in the double bond, benzene, not double bond. This is the way, that is right clockwise direction. This priority, 3 with respect to this bond, holding this bond long like this. That is R configuration. This is R configuration, this is S configuration. These two are called as stereoisomers. So in some reaction you get either this configuration or this configuration or mixture of these two configurations. The mixture is called racemic mixture. So this is about what is that in this mechanism you get this, that is geometry is retained. But in this mechanism we get this geometry inversion. What is the mechanism? It is SN2 mechanism involving. But look at that in the molecule. This is in the gaseous state, the substance is in molecule state, it is PCl5. When you take solid state, if it is solid now, with a solid, it is not in a molecular state, it is an ionic state. So two molecules sharing that is gives Cl minus becomes minus and plus deficient. So it's a mixture of these two side by side. That is ions. So it's an ionic substance. So when this ionic substance attack this PCl5 attack this alcohol, this phosphate this ion is attacked by this alcohol because it already contains lone pair of electrons, tends to form a chemical bond. So with this new chemical bond formation, a plus moving from here to here becomes deficient of this. Now it is intermediate formation. This intermediate formation, what is undergo reaction? What is the reaction? This chemical bond breaks, giving both electrons to this as H plus removed as H plus. If this is removed as H plus, it becomes minus, that is 0. There is no charge. So these electrons are given. This is no charge. This charge is removed. This is intermediate. Now this intermediate again undergo reaction because intermediate further react. This is still reactive till you get the end product is stable. So what is the reactivity? Is again action of lone pair of electrons on this phosphorus forming double bond with this double bond. So as this new chemical bond form, this chemical bond breaks and breaks away as Cl minus, taking both electrons minus. So it is minus plus, that is removed already, minus Cl minus. This is the intermediate with plus on this oxygen. This plus is now moving on to carbon of this. So reason that this chemical bond has a tendency of breaking and giving both electrons to this, moving on to this, and simultaneously Cl minus of this PCl5, that is PCl5 plus Cl minus. This Cl minus can attack this R because already chemical bond is there, it cannot attack from the other molecule, coming from other molecule, it can attack from the behind, other side. So this attacking what is that resulting in a new chemical bond begins to form, this chemical bond begins to break and finally breaks away into this and this. This configuration is reversed. ClR, it is ROCl. It is called inversion, complete inversion takes place. Byproducts, that is POCl. So it is called, mechanism is SN2 mechanism. Here the SN2 reaction depends on concentration this and this. It is SN2 mechanism. So geometry is completely inverted. This is the geometry we get. If you take this as a reactant, you get this as a product. SN2 mechanism. So that is if the carbon is chiral, stereo configuration is completely reversed. Reverse configuration. So this is regarding the mechanism of action of PCl5 on the alcohol. Next method is action of PCl5 on the alcohol. PCl3, it is phosphorus trichloride. This is even more reactive than PCl5. PCl5 is more reactive than PCl5. What is action? This OH group from the molecule replaced by Cl. So all Cl replace OH from 3 molecules of alcohol. Therefore, 3 molecules of alkane, haloalkane plus H3. This OH is removed as H3PO3. What is reaction? So product is this lower derivative of the alkane and byproduct phosphorus acid. Reaction mechanism. First step is always it is the PC. This P is reactive towards oxygen because of lone pair of electron tends to form chemical bond. As it tends to form chemical bond, this chemical bond begins to break away as Cl minus, taking both electrons. This becomes plus, this becomes minus. Here plus after polymer. Minus Cl minus. Now the intermediate, completely Cl minus is dissociated, independent. Now intermediate. Now this can act on this chemical. Now this action, what is that? This positive charge is straight to move into carbon, breaking this chemical bond. This chemical bond begins to break, this chemical bond begins to form. Attacking to the other side because it is not completely carbocation is separated. Carbocation is not completely separated. Still it is begin. So both are simultaneously. What is that? Begins to form, begins to break. So it requires attack to the other side only, Cl minus. So that is why we get what is the final is ClR. This is byproduct. P, Cl, and OH is removed as OH. Now this is a byproduct, this is a product. Final product is again it is inverted ClR. Here ROH. It is SN2 mechanism. Again it is a SN2 mechanism. The rate of reaction depends on both these reactant molecules. SN2 mechanism, it is inverted Cl minus. But byproduct. So in the byproduct, there are 3 Cl. One Cl is replaced by OH. That Cl replaced, that is bonded to this. This is replaced by Cl. Interchange. Next, this byproduct can act on fresh alcohol molecule. Reaction is end. Now further it is act on this. Still it is reactive. Same mechanism. Replacing Cl by OH. That is one Cl by another OH. Same mechanism. Forming and attacking from this again ClR. One more molecule product. That is one more Cl is replaced by OH. And still it is reactive. Now it can attack the fresh reactant molecule, alcohol, the same fashion. This Cl replaced by OH, same mechanism. So it gives ClR and the phosphorus. There is a molecule. There is all Cl are replaced by OH. Finally, this is rearranges itself into phosphoric acid, structure of phosphoric acid. H, OH, OH, O. And Cl, 3 products are there, all are inverted. SN2 mechanism. Here also step, here also SN2. All steps, no, here every step of reaction, no. There are 3 steps of reaction to get 3 molecules. All steps, no, SN2 mechanism. So that is SN2 mechanism here. Action of PCl3 on the alcohol is SN2 mechanism. Next is last reaction. Number 5. It is the action of sulfuryl chloride on the alcohol. It is the best method for preparation of fluoroderivative of alcohol because this method is known as Darzin's method. Darzin's method. The reason for this, the byproducts obtained are sulfur dioxide and HCl. Both are gaseous substances. In the reaction, these two gases and gas substances escape from the system, leaving behind only pure compound. They are pure compound of what is that haloalkanes obtained by this reaction. So that is called as best method for preparation of chloro derivative of alcohol, but the action of SOCl2. That is called Dorson's method, the best method. What is the mechanism involved in this reaction? Let us see the mechanism. Again, same kind, because sulfur is reactive towards oxygen because of the presence of this lone pair of electrons. Tries to form chemical bond. With this chemical bond formation, this chemical bond breaks, take electrons to this minus, and these electrons to this plus. See the plus formation minus within that molecule, intermediate. Plus and minus together. Again, this intermediate undergo reaction. What kind of reaction? These two chemical bond breaks. Cl minus H plus. So as Cl minus, no, as it is removed as Cl minus, this bond begins to, what is formed again? And H is removed, that is H is removed as H plus. These two electrons go back, bonding electrons go here, becomes O and neutralized and removed as Cl. So this H plus is removed as H plus and minus is removed as Cl minus SCl. Finally you get this product, is again intermediate product. This undergo further rearrangement. So what kind of rearrangement here? As this, what is that? This begins to break. This again begins to form chemical bond. This lone pair of electrons begins to form chemical bond, double bond like this. And this breaks as carbocation. And this Cl breaks, no, rearrangement. So simultaneous, what is that? Is not breakaway, simultaneous breaking and forming. Here this chemical bond begins to form, this chemical bond begins to break, this chemical bond begins to break, and one more chemical bond begins to form with this here. Simultaneous, like the previous one. So overall, no, it forming, it breaks, it breaks. That is intramolecular, what is that? Rearrangement. It is a rearrangement of chemical bonds within the molecule. Intramolecular rearrangement, just like SN1 mechanism, same SN1 mechanism taking place here. So with this same site attacks, rearrangement, because it cannot go from this side. It is there only, it can attack, break and begins to form, and the breaks now it forms this RCl and removed as SO2. Already Cl is removed, SO2 is removed. That is RCl product is retained. What is that? This is also SN9 retention. What is SN9 mechanism? Intramolecular nucleophile substitution here. Intramolecular nucleophile. Nucleophile is attacking this within the molecule only. That is by intramolecular rearrangement. SN9 mechanism. It is retained. Geometry is retained. So this method is the best method. So in this case, what I am talking there is, so PCl5 in the gaseous state acting on this is SN9 mechanism, and action of SOCl2 on alcoholism. Alcohol is also called as SN9 mechanism. It is retained. It is retained. But this case, it is SN2 mechanism. This is called SN2 mechanism. It is inverted. These are the mechanism. So product, this mechanism also important in examination, like competitive examination. That is why we need to discuss about the mechanism of these reactions with their formation or what is the preparation of the halides. Thank you.